Good morning. Today we are going to see about the lecture on design of RCC elements. Before going to the subject, let me clarify what is meant by design, what is meant by RCC and what is meant by elements. Design is somewhat nothing but it is a plan of a building or a structure or how to make a plan out of it. Plan is nothing but to make the drawings for those structures which is not yet built. It is in the dream stage. We are going to make drawings for that dream thinking. Okay, let me define what is meant by RCC. RCC is nothing but reinforced cement concrete. We all know about the concrete. Concrete is nothing but the mixture of cement, coarse aggregate and fine aggregate along with water. Why I said along with water is nothing but water is the main part in the concrete. It imparts strength and ensures durability for the concrete to make it stronger and better. Okay, let me define what is meant by elements. Elements is nothing but we have some elements in our structure, that is beam, columns, slabs, footings, etc. Okay, what is meant by reinforced? Reinforced is nothing but in the dictionary we have the meaning of reinforced as make it stronger. Here, to make our concrete stronger, we are reinforcing a steel bar inside the concrete. Okay, why we are using steel bars inside the concrete as reinforcement? Why not it is an aluminium, brass, copper, zinc or any other metal types we are using so far in the industry as a reinforcement inside the concrete? Because our structure after built, it is being exposed to various atmospheric conditions, that is, it is being constituted to thermal expansion and thermal contraction. It means that it is being exposed to hot climate also and being exposed to cold climate also. So that in order to make the concrete as reinforced concrete, we need to ensure both the materials, that is concrete and the steel reinforcement, to make it compatible. Compatible is nothing but the behavior of concrete and the behavior of steel should be mutually understandable. Understandable is nothing but when it is exposed to concrete, concrete will have some thermal expansion coefficient, whereas the steel will also have the thermal expansion coefficient. When it mutually understand, we can go for the reinforced concrete. For that, we need some values to justify what is the thermal expansion coefficient for the materials. For example, thermal expansion coefficient for concrete, it is 12 into 10 power minus 6 per degree centigrade. For steel, it is 13 into 10 power minus 6 per degree centigrade, whereas for aluminium, it is 24 into 10 power minus 6 per degree centigrade, whereas for stainless steel, it is 17 into 10 power minus 6 per degree centigrade. Okay, let me clear that the concrete will have a thermal expansion coefficient of 12 into 10 power minus 6 per degree centigrade, and for steel it is 13. It is more or less equal or nearby, so that we make those two to make it compatible to make the reinforced concrete elements. Okay. Another question, why steel and concrete will get compatibility? For this, the steel and concrete will get compatibility not only by the coefficient of thermal expansion, but also it ensures proper curing. After construction, steel it is being made in the industry under controlled temperature. The concrete which are constructed at the site, it is under cast in situ conditions. That's why being made a different atmosphere, how it can be compatible. By getting compatibility, these two materials should ensure something. What is that something? Something here is nothing but we need to give proper curing. After construction, we need to give some proper curing. Under curing, it will attain its strength, so that the structure we will have better strength when compared to other concrete. Okay, why we are talking as RCC and RCC? Why not it is PCC? Without reinforcement, we can call the concrete as PCC. Only the concrete which is made up of the composition of cement, fine aggregate and coarse aggregate, we can call it as concrete. We can rightly say that as plain cement concrete. It is not being reinforced. Being reinforced is ensures that we need to give some strength to the structure. Okay, what is mean by elements? Elements. Let me have some analogy for those elements. For example, consider a body. The body is having eyes, ears, head, shoulders, hand, legs. Each part is doing some work. In the same way, for a structure we are building a skeleton structure like our body. It is being made for some work. That work is nothing but it may transfer loads, it may be a vertical member or it may be a horizontal member or something else. Okay, let me clarify what is mean by elements in a structure. Starting from the bottom, this is called as footing. From the footing, we are projecting a structure which is vertical in nature. This is called as column. From the column, we will be having some beam at the ground level. This is called as plinth beam. Above this, we are raising our columns. Here, we have a slab with beam arrangements. The slab, which is an horizontal element, after that the column will be continuing. These are the elements so far we have it in the structure, starting from footing, column, beams and slabs. Okay, now we have seen about what is meant by design, what is meant by RCC and what is meant by elements. Okay, we have a code book for those designs to be detailed in a proper way so that we can ensure safety for your structure. The code books meant for designing RCC structures are IS 456 2000, Code of Practice for plain and reinforced cement concrete. We have another code book, IS 875 1987. It is mainly meant for code of practice for the design loads. Okay, let me come to the picture now. What is meant by design loads? Now we are talking about the RCC, PCC, reinforced cement concrete and the elements so far happening in our structure. Here, the new term, what is meant by design loads? You all know we have certain type of loads to be acted in our structure. We can classify the loads as First one, dead load, we can call it as DL. Then live load, we can call it as LL. Then wind load, WL. Fourth one, earthquake load, EQL. These are some of the main loads which are being acted upon our structure to make it stable, to retain the structure for a long period. Okay, let me have some questions from this, whether the loads are being acted individually or we have some combinations for acting of your loads. Yes, we have some combinations of loads, that is dead load plus live load. We can have dead load plus live load, this both simultaneously it is being acted, but without dead load the live load can't be acted upon, because dead load is nothing but self weight of the structure. So without dead load the structure won't exist. Okay, the next combination is nothing but dead load plus live load plus wind load. After getting into the structure, dead load, that is the self weight, then the live load, that is the new load entering upon into the structure. For example, if it is a library, we have a book racks, we have a computers, we have a tables, chairs. These are some of the live loads. Then the man entering into the slab is also a live load. Okay, what is mean by wind load? Wind load, it is purely caused by the wind. The wind, it is acting upon to your structure in the lateral way, that is in the horizontal direction, in the lateral way. Okay, then the third combination may be dead load, live load plus earthquake load. Earthquake load is nothing but a sudden cause of load due to seismic activity in that area. We'll get some earthquake load which is entering from the soil substrata to your structure. So that we may have some doubts, why can't it combine wind load and earthquake load in a single combination? For the least criteria, if a cyclone occurs, the wind may be the major area. If the earthquake activity is happening over there, EQL load is the major area. So we don't get the possibility of having both the loads. The major area will be wind load. We can take this combination and we can design your structure for this combination. When the earthquake load is the main area in that structure is being built, we can take the earthquake load as the priority cases, so that we have get the combinations as dead load plus live load, dead load plus live load plus wind load, dead load plus live load plus earthquake load. Okay, these are some of the load criteria which are being used in a design of RC elements. Okay, let me come to the course now. We have 5 units. In the first units, we have described about the introduction of RC elements. So far I have told you about the introduction of RC elements, what is meant by design, what is meant by reinforced, why not it be steel and aluminium, then what is mean by elements. Let me clarify that the design of RC elements what it is. Then now we are entering the subject. Unit 1 is about the introductory part. Then we have certain methods for the design and we have some objectives for the design and how we can able to design the elements under those methods. Okay, first thing, aims of design. What is mean by aim? We have certain aim to lead our life. In the same way, when we construct a structure, the structure should have some aim. That is, aim is nothing but it should satisfy some criteria. That is, if a client said, I want to build a home, it should be durable for some 100 years. Okay. So, my main objective of design engineer side is that I need to ensure safety, then I need to ensure serviceable life of your structure and the structure should be durable. Okay. So, here aims of the design includes the main thing the client will tell the engineer that I need to build a home. It should be economical. Economical in the sense my budget should be on the lower end. First thing, the budget, we can call it as economy. First thing, I should ensure economy from the engineer's point of view. The second thing, mainly the client forcing about it is the functional requirements. I need 2 BHK rooms, that is 2 bedrooms, 1 hall and kitchen I need, or else I need a school building having 56 classrooms, or I need a hospital building having n numbers of rooms. I need an operation theatre. Likewise, from the client side, we have some requirements over there for the functional utility of our structure. So, second thing we are thinking about it from the designer side is the functional requirements. Then, the third thing, after coming to the economy, I need to think about the functional requirements, how far it should be functional at the lower end to satisfy my client. By considering these two points, I need to give the client the life of the structure. The main important objective under my design is life of the structure. Okay, how to ensure these three by the designer's point of view? Okay, first thing, the designer will think, first one, strength, second one, stability, my structure should be stable enough. Then third one, serviceability. Okay, the main objective from my design part is that first thing, I need to ensure strength to my structure, whether what are the materials I'll be choosing for the design, then what are the materials it would be under low cost, I need to think for that also. Then I should ensure second one, stability. The materials which I am using in that locality, it should be stable enough or not. Whether my structure is exposed to severe hot temperature or severe cold temperature, whether it is stable or not, or it may be under cyclone. We are seeing nowadays in Gujarat, we are having many earthquake prone zones. Our Coimbatore is under zone 3. We are somewhat under safe side, but we are now moving under the tectonic movements. Based on the tectonic movements, we are moving from zone 3 to zone 4. So, I need to ensure stable and more strength for my structure before designing stage itself. Then the third one, serviceability. Serviceability is nothing but how far my structure is stable after its construction. Before designing, I need to think over it for all these stages. Why SSS is needed? SSS, first S is strength, second S is stable. Both, when I get strength and stability, I can ensure safety to my structure. Then third one, serviceability. What is meant by serviceability? Serviceability is nothing but how far my structure is stiff throughout my life period. For example, after getting older, when a kid is growing, after getting is older, it will be subjected to some diseases, right? In the same way, the new structure is somewhat better when we use it. After some years, it will be not maintained properly, so that we'll be getting some maintenance problem. In the same way, we need to ensure serviceability. Serviceability is nothing but the starting stiffness should be prolonged throughout the lifetime of your structure. The first thing. The second thing, we need to ensure durability. Durability is nothing but after constructing a structure, it may be under corrosion part also. When we construct a structure in the offshore sites, it will be subjected to corrosion. Why the corrosion happens? When the steel is exposed to atmospheric conditions, it may get corroded. When the starting stage of corrosion existed, when it prolongs into the reinforcement, it got corroded for the entire structure, so our structure will get failed. So I need to ensure all these measures before in the designing stage itself. So the third term, serviceability, ensures that the main thing, the structures should have enough stiffness, then it should have enough durability. So the main objective of my design is that first is strength, second one stability, and third one is serviceability. Okay, let me conclude the today's lecture. I'll have some recap over that. First thing, the design of RC elements. Design is nothing but to make a plan of a building or to make a drawing out of it. We need to have some thinking capability over there. So to make a plan of building, we'll have some drawings out of it. What is there in the future we are going to construct. Okay, that is what the design is of. Second one, reinforcement. We need to ensure the strength and stability to our structure. That's why we are reinforcing something into the concrete to make it stronger. To make it compatible, we are making out of it the steel and concrete. It is a huge, big, challenging area to make it compatible, so that we are ensuring proper curing after construction process. Then we have gone through the elements. What are the elements so far? The main elements or the load carrying elements in our structure from the footing, column, beams and slabs. Okay, let me have some code of practices used for design of RCC elements, that is IS 456 code and IS 875 code, and then we have some certain loads for those structures which was predominant in our structure: live load, dead load, wind load and earthquake load. Then we have entered the topic aims of the design. Aim is nothing but the main objective of the design, what I am going to do for my structure to satisfy my client. Main thing, I need to think over economy, then the second thing, the functional requirements, then the third thing, the life of the structure. To ensure economy and to satisfy the functional requirements and to satisfy the design life period of my structure, I want to promise three things, that is strength, stability and serviceability. Strength and stability, it ensures safety to my structure. Then serviceability, it will ensure stiffness and durability to my structure. Thank you.